this is Algebra 2, Lesson 35, and this lesson has several parts. The first part is going to be angles in polygons. So we know that if we have a triangle that has three angles, A, B, and C, and if we add them all up, we're going to get 180 degrees. All right, what if we have a four-sided figure like that? Well, we can divide that into two triangles. This triangle's angles are going to equal 180, and that triangle's angles are going to equal 180. So we got 180 plus 180 is going to be 360. Okay, so what if we have another figure? Well, this one we can divide into 1, 2, 3 triangles right there. And so that would be 180 plus 180 plus 180, and that would be 540. All right, so we can see that there is a basic formula for finding the amount of if you add up all the angles, what it's going to be. And so that's n minus 2 times 180. N is going to be the number of sides of your polygon. So if we have 1, 2, 3, 4, 5, 6-sided polygon here, we would say 6 minus 2 times 180, which would be 6 minus 2 is 4, 180 times 4 will be 720. And we can see that by dividing this into some triangles here. And we would have 180 in that one, 180 in that one, 180 in that one, and 180 in that one. All right, so you can use that for any number of sides. All right, those are for your interior angles, so the measure of all the interior angles of a polygon. For exterior angles, if we imagine, let's imagine a shape here. Let's start with a triangle. Well, if we started here and we go around, and then we start here and we go around, and we start here and we go around, once we go all the way around this shape, that is a circle, and it has to be 360. Now, what if we have more sides? Well, if we go around, you'll see that every single one of those exterior angles still has to equal 360 because we just went in a circle. So the measure of all the exterior angles on any figure is always going to be 360. I don't care if it's got 20 sides. Those angles are always going to add up to be 360 because it makes a complete circle all the way around. All right, so 35.1 gives us a crazy looking figure. Okay, so it looks like that. Straighten all this up here. All right, and it tells us that this is 80, this is 40, this is 50, this one is 65, this one's x, this one is x plus 55, and then inside of here is y. Okay, so we know that all of these angles together have to equal 360, so we can just say x plus 55 plus 80 plus 40 plus 50 plus 65 equal 360. Okay, then we'll just add all those up, and so that's going to be 55 and 80 and 40 and 50 and 65. It's 10, 20, 28, 29, 290. And then we're going to say 360 minus our 290. Actually, let me write that out. So we're going to say we still have an x plus another x, so that would be 2x plus 290 equals 360. There we go. Now we're going to subtract our 290. We get 2x equals, minus 0, 0, 6 minus 9, that would be 770. Okay, and then we have to divide by 2. And we're going to get x equals 35. Alright, so there's x. Now we still have to find y. Well, if x equals 35, we know that these opposite angles, that's a straight line, have to equal the whole thing right here. This straight angle has to equal 180, right? So we're going to say 35 plus 55. That'll be 90. So if this angle's 90, then that means that side's 90 as well. So that's 90 degrees. Alright, so you just add them all up, and all of your exterior angles have to equal 360, and then you just subtract from there to find the answer. Okay, so the next part is about a quadrilateral that's inscribed inside of a circle. Alright, so let's say that we have a circle, right? And we've got a quadrilateral inscribed inside of it. So we've got A and B and C and D, and then these are connected. Like so. Now you remember that C, so from here to there, is double whatever C is. So the arc from DAB, that arc right there, is equal to 2 times C, right? Okay, so that gets us all the way from, use colors here. So if we went all the way around like that, that corresponds with C. Now our A right here, its arc is going to correspond from all the way around like that. Now we know that these would have to equal, so that one is arc, we'll call it BAD, right there. So that's that pink one. And my green one is 2 times C. So my pink one is going to be 2 times A, right? Because the measure of the arc is double whatever the angle is. Okay, so then we're going to say that those two added together have to make 360 because they go all the way around. So DAB plus BAD equals 360. Right? Be the green one plus the pink one are going to equal 360. That means that these two have to equal 360 as well. So if we said 2C plus 2A equals 360. Now, there's something important that we can pull from this. If we divide all of this by 2, we'll see that C plus A equals 180. And that tells us that any pairs of opposite angles, see how these are opposite from each other, are going to equal 180. We could say the same thing about these. This one and this one have to equal 180. Alright, so a question related to that is going to give us a diagram of a circle, and it's got an inscribed square inside of it, and it has 75 up here, and it tells us this one is 80, and this one's y, and that one's x. And then right down here, this is 50, so this arc right here is 50, and then we have to find this arc right here, which is z. We have to find x, y, and z. Okay, so for y, let's see. How did I do this. All right, x is going to be, oh, yeah, super easy. So opposite angles have to equal 180. So if this one's 80, we'd say 180 minus that one's 80, we get 100. So x is 100. 75, we would say 180 minus 75, because this one and this one correspond. They're opposite angles. Added together, they have to make 180. If one of them is 75, we just subtract, and we're going to get 105. So y is 105. Now we have to figure out what z is. Well, we know that if this is 80, then our area around this right here, so if that dot's 80, then from there all the way around to here is going to be double 80, which will be 160. Well, if this part's 50, we're just going to have to say from here to here is 50. The whole thing is 160. We're going to say 160, take away that 50, and we're going to get 110. So z is 110. All right, hope that made sense to everybody. Okay, one more part to this lesson. I know this was a long one. This is fractional exponents. All right, so 2 to the 1/2 is equal to the square root of 2. Okay, so the 1/2 means square root. If we have 2 to the 1/3, that's going to be equal to the third root of 2. All right, and then 2 to the 1/4 would be equal to the fourth root of 2. Okay? All right, what if we have x to the 5/3? Well, that's going to be the same thing as we could say it was x to the 5th times 1/3, because you could say 5 times 1/3 equals 5/3. Or you could write it the other way, and you could say x to the 1/3 times the 5th. There, okay? That is going to actually equal x to the 5/3. On these, you're going to take your bottom number, and that goes outside your radical sign. 3 goes there. Okay, so that means the third root of x to the 5th. All right, so 35.3 asks us to get 4 to the -1/2. All right, so first I got to get rid of that negative, so I'm going to put a 1 over it, and I get 4 to the 1/2. And we know that 4 to the 1/2 means, so the bottom number goes outside here, so that's the square root of 4 to the 1. So basically 1/2 means the square root of, the square root of 4 is 2, so I've got 1/2. 4 to the -1/2 equals 1/2. Okay. This one has -27 to the -1/3. Okay, so first thing I have to do is get rid of this negative in my exponent, so I'm going to put a 1 over it. Okay, so that means the third root of -27, which would be -3 times -3 times -3. 3 times 3 is 9. 9 times 3 is 27. And it would be -27. So that equals -1/3. All right, let's try another one. 35.4 is, oh, I just did that one. 35.5 is 16 to the 3/2. Okay, so that's really going to mean we could write that as 16 to the 3rd times the 1/2. Or you could write it as 16 to the 1/2 to the 3rd. The easiest way to think about this is whatever's on the bottom goes in your radical box. So that's the square root of 16 to the 3rd. I'm going to square root it first. So I'm going to say the square root of 16 is 4. And then I need 4 to the third. 4 times 4 is 16. 16 times 4 is 64. Okay, I could have said 16 to the third and then found the square root of that, but that's a lot harder than saying what's the square root of 16 and then multiply that to the third. This one is negative 8 to the negative 2 thirds. Okay, so first I got to get rid of that negative sign, so I'm going to put a 1 over it, and now have negative 8 to the 2 thirds. Okay, and now whatever is on the bottom is going to go on my radical box, so I'm going to say 1 over the third root of 8 squared. So I'm going to third root that first, so 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Alright, so I know that's 2. So it's going to be 1 over, and that's still got a negative sign. Negative, see, I can cover that up. I'm not including it in my rooting here. Alright, so I've got 2 squared, okay, and then 2 times 2 is going to be 4, so that is negative 1/4. Is the answer to that one, negative 1/4. Alright, I could have said 8 times 8 is 64 and found the third root of 64, which is 4. But it was easier to find my root first and then find my exponent. Alright, any more of those? No. Okay, so do the practice problems, pause the video, and then I'll work on them. Alright, so hopefully you pause the video and work the practice problems. This first one says find the sum of the interior angles of a 14-gon. So that 14-gon just means a polygon with 14 sides. So the formula is n minus 2 times so 360, 180 times 180. So 14 minus 2 would be 12. 12 times 180. And it's 2,160. That's the answer to A. B is really, really easy. B says to find the sum of the exterior angles of a 14-gon, and that is 360. No matter how many sides it has, the exterior angles always equal 360. Alright, C and D are a little harder. C is 64 to the negative 1/2. Okay, to get rid of that negative, I'm going to put a 1 over it. Now it'll be 64 to the 1/2, which means 1 over the square root of 64, which is 1/8. So 1/8 is the answer to C. Alright, D is 64 to the 2 thirds. Alright, so that really means the third root of 64 squared. I'm not going to square 64 first and then try to find the third root. What I'm going to do is find the third root of 64 first. And I'm pretty sure it's 4. 4 times 4 is 16, and then 16 times 4 is 64. So it's 4. So that means 4 squared, and 4 squared is 16. So the answer to that one is 16. And you can use your calculator on these roots. If you squared it first, you're going to end up with giant numbers. Alright, and then E, negative 125 to the negative 2 over 3. Okay, so first I got to get rid of the negative in my exponent, so I'm going to put a 1 over that. And I'm going to say negative 125 to the 2 over 3. And then I'm going to say negative, I'm going to put my 1 there. And I'm going to say it's the square root of the third root of 125 squared. Okay, there's my negative sign. The third root of 125 will be 5, because 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. So that would mean that this whole thing equals 1 over negative 5 squared. And then 5 times 5 is 25. So we've got negative 1 over 25 is the answer to that one. Negative 1 over 25. Alright, hope that made sense to everybody. And the lesson that I assigned in class was lesson 35 for homework. And you can just take a picture of it if you can't make it to class, and you can send me the picture, or you could just bring it to class next week if you're not going to be there this week. Alright, bye.